We are now on 10.2 geometric series. A geometric series is one where every term has something in common. We call that something in common the common ratio R. So you'll see geometric series mostly in this form. And so let's take a look at an example. The two things that you care most about geometric series is this first term, and the first term we call A, and then R, which is the common ratio, what they have in common. And we care about this because we're going to be able to find what it converges to, if it converges, with using A and R. So I'll show you that in a second. But first, let me show you how to find A and R. So there's two ways. You can either be given this geometric series and put it in this form, or you can write it out and see what the series actually looks like. So let's do the first way. So I'm going to go ahead and put it in this form. So this is really just 4 divided by 2 to the n using our exponent rules. 4 divided by 2 is 2. So already, look how easy that is. You already have it in this form where you have 2 to the n, and R here is your 2, so you already have R is equal to 2. To find your A, which is your first term, literally just plug in your first term, that's n is equal to 1. So 2 to the first power is 2. So already you have your A and your R. Another way to do this is to actually write it out. So if you do n is equal to 1, then you plug in 1, that's going to be 4 to the first power, 2 to the first power, 4 divided by 2 is 2. Then if you plug in 2, that's going to be 16 divided by 4 is 4. And then if you plug in n is equal to 3, then that's going to be 4 cubed, which is 64, and then 2 cubed, which is 8. 64 divided by 8 is 8. And then that goes on forever. So the way that you find A is literally the first term, like you actually did it already. So A is equal to 2. Okay, that's how we got that. And then what's R? To find R through looking at the actual series itself, you just take the second term divided by that first term. So 4 divided by 2 is 2. So that's another way to find it. But why are we finding A and R in the first place? Well, because there's this rule that if you take the absolute value of R and you find that it's less than 1, then that tells you that your series converges. And if you take the absolute value and that's greater than or equal to 1, then that tells you that your series diverges. In this case, our R is equal to 2, so 2 greater than or equal to 1 tells us that our series diverges, right? Because 2 is now less than 1. So our series for sure diverges. That's for this problem. But what if our series did converge? Well, if our series converged, then we have a formula that tells us what it converges to, and that is where the A comes in. That's why we find A. So if you find that a geometric series converges, you go straight to finding what it converges to. If it diverges, then you're done. So let's go ahead and try out some examples in the next video.